Hello guys, welcome to AtCoder Beginner Contest to 8. Uh, Let's say pretty much normal AtCoder Beginner Contest. Aside from one issue, you see I can't try to follow Formula 1 and they happen to have a race today at 4 p.m. my time, which is 1 hour after the contest starts. So we gotta go quickly on this one. So I guess I will just solve problems as quickly as possible and not paying too much attention to penalties and stuff. And from there we'll see how difficult it is today, whether we can solve everything, and if I will be able to leave earlier for the race start. Because it may so happen that it will be actually the most important, the most interesting part of the race, I guess. So yeah, I kind of expect that you don't really need detailed explanations for A, B, and probably C. Because if I'm honest, like most of the time ABC is simple implementation and D can sometimes be tricky. Especially if it's geometry, but other than that it should be also some well-known algorithm. Same for E, and then F occasionally happens to be something interesting. We'll see how it goes today, and that's basically it. That's basically it. So the contest will start in a second now. Good luck to us, good luck to you if you participated in this contest. Yes, go. Tasks for printing, casual, open and submit. Okay, is it possible to get a sum of B when throwing a dice with 6 faces 8 times? So what I imagine we have to do is we just read A and B, and we print something like A is at B is at least A, and B is at most 6 times A. If so, then we print yes, otherwise we print no, and that's all we do. Because any combination in between looks like it's achievable. Okay, so we didn't make any mistakes there, good to know. Problem B, the coins used are factorial coins, cool. The cashier has stock 100 kind of every kind of coin, and he's going to buy a product worth P yen by giving the exact amount without receiving change. Okay, so at least how many coins does he need to use in his payment? Well, that's simple. The factorial number system and pretty much every other system works in such a way that that you can use greedy algorithm to get the minimum number of coins, and it works for all number systems in which every next base or coin is at least twice as big. That's a common fact in mathematics. So while this is less than, we're going to push back another factorial. It's actually, okay, I'm confusing myself here. I think I should just do something like that. Yeah, that's the smartest, I think. So we computed all factorials that can't possibly take part in our adventure, in our, I don't know, in our problem. No, okay, what we actually will do is we can use std_diff to divide p by last factorial, so that c gets incremented by quotient and p gets changed to remainder. I assume that's how it works. Nothing should overflow because p is only up to 10 to the 7th. Also, I did not use 1 twice. Oh, that's going to be, I'm stupid, but that's going to TLE. Never mind. I forgot to put the entry from the vector of factorials. So 5 minutes of penalty there, but the most important fact for us is that like we are not running out of contest time, right? It's more valuable than penalty time. If you're not getting all problems, you kind of don't care, right? So in problem C, you can prove that greedy algorithm works. By the way, just imagine that like actually representation in factorial number system is unique if you limit your digits. If you don't, then it's not unique, but it's clearly possible to change multiple occurrences of the small coin to one occurrence of the bigger coin and save coins. So in problem C, there are n citizens. Each citizen has a national ID, AI. Okay, so we have an array. Takahashi has key pieces of sweets, decided to hand out pieces to citizens such that when he has n or more pieces, hand one piece to every citizen, otherwise let k prime with number of pieces 1, hand out one piece to each citizen with the k prime smallest IDs. Okay, once again, question std_diff is our friend. Apart from me not reading the description, the constraints rather. I'm not sure that you can divide. I'm going to specify type here explicitly. K by n, right? So the way what I'm going to do is like quotient is what everybody gets, remainder is what we distribute based on ID. So the way we do it, unique IDs, right? Pairwise difference. Anything wrong? Okay, I don't know. b of size n should initially hold that, and then I should, like, I needed smallest IDs, but I also needed them indexed, right? So I say like indexed A. I don't know if it's the best name, but whatever. I at index I, it's the index in the sorted order. What do I want from that guy? I want second index because it's what originally was I. And I assume that I want to increment b at that index. Oh, that's okay. For some reason we have to print them on separate lines, but that's okay. I don't care about penalties, I already said that. Okay, compile error, nice. Expected primary, wait, div is not template? Okay, then I will just change that to long because I don't really want to experiment right now. So, yet another simple implementation problem. Okay, got accepted. D. There are n cities m roads, so we have a graph. We'll have to compute some bizarre sum. Some things never change. The roads are one way, and also they take some time, apparently. What do I have to do? Fs, okay, that's not yet relevant. Does it work if there is white space in between the operator? I doubt it, but maybe it does actually. Does C++ just ignores white space? It can't, right? Because sometimes it's valuable. Okay, I better figure it out someday. Like, I would not leave it even if it worked this way. I just think it's better when you have some code stuff going on. So FSTK is the compute the minimum time needed to get from city S to city T. Here, other than cities S and T, it is only allowed to pass through cities 1 through K. Fascinating. I am not a specialist, but sounds like Floyd Warshall. And sort of like as if we wanted to sum up all the numbers that like appear in Floyd Warshall distance matrix throughout the iterations, right? Because how do and even index k is exactly what you needed, right? So I'm surprised that you don't want to mod it. Is it so small? 400 times 400 times 10 to the 6? Yes, probably. But even more, I guess that we don't need long integers in our distance matrix, which is surprising. But nice to know. No, probably not like that. Most surely like that. I also happen to make them global for some reason. I don't know, maybe someday I'll add it to my template because I use it way too much, I think. Yes, is there anything wrong? No, I don't think so. Oh, it must have C++ 11 syntax going on. Right, then it makes sense. Bro. Okay. Check it out. What happens next is, I believe, DAB gets minimum of DA, B, and C because there may be multiple rows, right? So you can't just assign. I'm pretty sure. So what happens next is you loop over all cities that you use as an intermediate step. Then say like, okay, I loop over that starting city, I loop over finishing city, distance of start and finish gets minimum of distance starts to k plus distance k to finish and distance of start to finish as this. And what we do next is, I believe, oh, we can do it just here, right? I'm a little suspicious. I'm going to grab those two loops and copy paste them at the end. Ideally you want to test it, but looks legit, I don't know. Oh, by the way, this is the second version of this problem, so maybe we could have found something interesting. Oh, I am stupid. For multiple reasons, so we will figure them out really soon. So, first reason is that I forgot this. Second reason is that I forgot this. But why I got a runtime error, I actually don't know. So it sounds like it's time to actually start testing something before submitting. S hides previous declaration. What is the previous declaration of S? Oh, that makes a lot of sense. Does not sound like it. Oh, if we don't, okay. So around 5 mistakes already in this problem, but nice. Nice. Well, something works. Actually, this also works. So what's wrong here? I am legit confused. I'm very confused, if I'm honest. Oh, okay, never mind. I can't type. Okay, we should be getting this one soon. If we're getting 517 here, it's pretty much guaranteed that it works. Yes, okay. So more penalties are necessary, but the most important thing is the speed at which we are moving. I believe you have never seen me solving ABCD in 20 minutes before in the screencast. Okay. Because I really want to see that race start, so gotta work harder. For how many integers at most n is the product of digits at most k? Interesting question. Product of digits can't take that many values. Am I right? I'm pretty sure that it can't take that many values. Let's think. Like, theoretically, it can take 10 to 11s, 10 to 18s, right? But practically, product of digits is the number of the form 2 to the power of m times 3 to the power of m times, I should say 2 to the power of p a1. No, in general, it's p1 to the power a1 times several things, and then times, I don't know, pm to the power of am. If you don't think, then you understand that pi is, in our case, in this set 2, 3, 5, 7, not a big set, right? So a1, I'm pretty sure that a1 is limited from above by something like 54. A2 is limited from above by something like 36, and A3, A4 are at most 18. So therefore you get like solution like this. How to compute it quickly? Well, I guess you need a frequency map of all possible products, whatever that means. Digit products. Like, we are going to disregard the special structure of this set and just say the following. So how do we loop over all kind of digits of n? Okay, we are going to have, instead of one such thing, we are going to have two. Now 0 is already less than n. By the way, I should read input at some point. I have no idea, if I'm honest, why k is such small. Maybe so that our frequency table works faster, but still no idea why. Like, it's not much of a difference, right? Oh, or is it? No, it's not, because like we already talked about that. Imagine that all your digits are 9, then you're kind of getting less than 10 to the same power. So most you're getting 9 to 19, which I assume also fits within long. So it doesn't make sense to have stricter constraints on k, but whatever. Well, that is incorrect, actually. Once you think about it, the reason is that I want to iterate over digits of n in increasing order. So I read them as a string. What do we do next is I assume that we just can't use really k, so at most, right? It's gonna be our loop. Now here you have to be a little bit careful. I assume that you can select new CNT, then you select, you know what, swap CNT and new CNT, please. And here you have to actually update CNT, of course. How do we update it quickly? No, we don't have to bother about how quickly we update, worry about how quickly we update. Yeah, my syntax highlighting does not know about the existence of C++17. If you're wondering why it shows that it's invalid. Or maybe it knows and therefore it shows a white dot to say like, hey, it works only with C++17. Anyway. Can I try it like that? So this is Python. So probably like this. Not yes, yet less than n, right? At 1 is 1. There's like, you're going to say that there is actually what I think we are going to do. No, okay. Like want to loop our first digits as long as it's not greater than that, as long as it's smaller than that. What do we do? So we have No, okay, forget about that loop, that is not good. So CNT0 is the guys who are already smaller than n. Already smaller than n, right? How do we can add anything to them, right? So, and they will remain smaller. So the way it works is we take key multiplied by current digit, which is not actually first. Yeah, I called it F because I thought it's first, but it's just current digit. So this gets incremented by value, I believe. Then for key and value in guys for equal to n, well, actually, kind of stupid of me, because there is only one integer equal to n, and it is actually like the prefix of n. So you don't do that. You just will update it more careful. So yes, also get rid of this. Here should go the product of digits of n, which I assume is long. So what actually happens is product of digits of n gets multiplied by an I minus 0, I assume. Right? And then I say like, okay, there is one thing that starts like this. Is it true? Not sure. I should just say CNT, no. Oh, that's correct. Like, nCNT gets assigned to CNT, and out value of CNT, which is currently in nCNT, gets dropped out of scope here. I'm still a little suspicious though. The reason is that we should count all numbers that have less digits at n somehow. How the numbers that have less digits at n start? They start with several zeros, but those zeros, we exclude those zeros. I'm not sure that this is actually correct. No, I don't think that this is correct. Let me explain. So P is the product of digits before that moment, including that. Before that. Okay, here P is the product of digits up to current point. So there are more digits, more numbers that are smaller than n. some of them start like this. So they had a common prefix of P with product P. And now we take a smaller digit and say like, hey, there is exactly one such number. Sounds legit. I don't know if it is, but I remember solving very similar problem on AtCoder recently. Okay, so it does not work. By the way, how long? Oh, how long does it take? It does not take long. It does not take long at all. But more importantly, via our content, right? So what I propose is to debug a bit and hopefully speed up, because that is slow. By the way, you may have noticed that recently I switched to using std error for debugging, which I believe is just supreme. Honestly. Okay, so there is one number with product of digit 0, which technically should not happen. So what I believe we should do is we should do this. Yeah, my music just stopped. So like if it's first digit that you can't really use 0, because that's illegal. Now we are undercounting. Yes. Yes. So the problem, I assume, is that we kind of did not try to have several zeros on in front of our number. How exactly do we solve it? I think that we say something this. If I, so if we already know that we are smaller than n, if we take several, put several bunch of zeros in front, and we may actually start. Unbelievable, unbelievable. Also, we can be actually equal to n, right? Or can we? I don't think we surely can take it here, because no, like here we are counting only the values that are smaller. So I also think that we should slot this in. But here we iterate all digits, so I should just write comments. Does not actually start with zeros, so I will say shorter than n. Has fewer digits than n. I'm just getting too long, so I'll slot it here. So that's approximately what I want. Now what do I do? I think that I say NCNT at D. Because like I only have one digit and the product of this digit is D. Makes sense. Okay. It will take some time, not much though. Like, that's IO being slow, not the program itself. Should just disable. Turns out sometimes we have to comment C error. No, the answer is clearly the same, so we can just submit. Nothing interesting here. Like digit DP, standard digit DP with an ordered map, which like you have to believe in yourself some sort of. And just like this in 50 milliseconds, yeah. And under 40 minutes, we have more than 1 hour for F, which is cumulative sum. For non-negative integers n and m, let us define function f of n m as follows, using a positive integer k, f and m, and if n is equal to 0 is 0, if n is greater than 0 and m is 0, and it's n to the power of k. Wow. Okay, sounds smarter than I wanted it to be. But let's think. Wait, what's the trick again? I don't understand. What's the trick? No, okay, we have like some recurrence relation. I don't care much about that recurrence relation, although it looks like we what it looks like is as follows. So we have a bunch of zeros in the first, I don't know, row or whatever, then we have n, then we have n squared, then we have n cubed, etc. And here we probably have sum of up and left, so n, and this is n squared plus n. I'm still struggling to understand what's the idea of this problem, even though this is like this. I should just keep that because it will get too long quite quickly. So next guy will be just plus 2n, but like, does it even matter? I think it does not. It just does not matter for some bizarre reason. I must be missing something in the problem because it's so. I just don't get it. You will see in a moment what I mean. I just want to fill this table a bit to maybe find my mistake. I just can't see it. Okay, so anyways, we have this table. Oh, I was not paying attention, but whatever. Wait, what? Oh, okay. Never mind. Still. Oh, now I get it. Okay. 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 Yes, AtCoder outsmarted me once again. Well, at least now we have a nice table. Sort of table of values. I remember very similar sequence, but I have no idea what it was. No, please, no. But it can't be, right? Okay, good. Doesn't look like we are getting it on time. Okay. M is small. M is small. So column is small. Interesting. What will happen in the next row, I wonder? Like this? Okay, this one I guess it. What happens here? No, please tell me that it's not it. Okay, what happens next? It can't be, right? It can't be. Please state that it's not. Okay, so we are adding this in. Now we have this, and we are adding this in for a total of 3, 6, and 10. Okay. Much sense does it make? Let's think. So imagine we are going to sell NM, right? I wonder what is the contribution. So we are going to sell NM of this table. I wonder what is the coefficient Cn near n small to the power of k. My logic is as follows. To get to some cell, so we effectively have a table, right? With with not that many rows and columns. With not that many columns, but with many rows. I actually drew it incorrectly, but whatever. Somewhere here we have n to the power of k, which not surprisingly travels along. There is something else, but like the coefficients above are clearly zeros. And coefficients here are ones. Coefficients here are ones. 1, 2, 3, 4, 5, 6, 7. 3, 6, 10, 15, 21, 28. So in general, it sounds like it's a binomial coefficient, right? So which one? Get a sync. So here starts the triangle, right? So on this cubed, but you get it. It's a triangle, binomial triangle. What is the value here? Normally, you choose. Okay, so you have to travel how many? 1, 2, 3, 4, 5. If this is first and this is m, then you have to travel m minus 1 to the right. So you choose. You're clearly choosing. So we have sum over and small from 1 to capital N, which is too slow, but hear me out. N to the power of k times some binomial coefficient. Here we get this. We also get it here. Normally it works like this. And this is n, right? So how many steps do we have to make? Capital N minus small n. Now we have to compute that sum. Modulo 10 to the 9th plus 7. Fascinating. Let me just write it down. Also, what is the input? NMK. Okay. Now you can understand why m is small, because binomial coefficient should not get extremely large, because then you won't be able to compute it with simple math. You already need modular division, which is uncomfortable, and more problems will come if m is too big, I believe. NMK, right? Oh, I'm missing restart apparently. How unfortunate. I'm pretty sure that it's included, even if you don't see it straight away. No. Once again, I will name them N and K because it's just so common to have N choose K, so I don't even know what else we can say. exponent is not modular integer. Does not make sense. No, it makes sense, but it's modular integer, modular different module. If you know what I mean. Wait seconds. I must be stupid, right? Let me just write down the formula and then we will come back. So for n in range 1 capital N plus 1, what's b of n minus n plus n minus 1 n minus 1. This can be removed. No longer need this. I keep forgetting. No, I actually just don't know what exactly it offers with mod int. Okay, so you can invert. That's good. Oh, there is spawn. Which is good. And it takes long, which is okay. There is inverse, and then there is no binomial coefficient, normal. It is completely normal because this just this. What if we just make both of them longs and then cast whenever necessary? So what happens next is C and K surely gets multiplied by n minus I, and C and K I believe gets divided by I plus 1. Now this is clearly not fast enough. For some reason K is not that big. Now M small, okay, we can understand it, probably. Although not really. So there's got to be some trick to it. There's got to be some tricks to it. Like ideally, I would like to say that this sequence is periodic modulo something, but I don't see what is the modulo or how we could possibly get one. How probable is it that we actually solve it? I just wondering. Okay, so even with our terrible penalties, we are 71st because I kinda turned on second gear. Yeah, with those 50 seconds on I. Okay, this is kinda not very representable of Ukraine, because obviously no. I guess no higher rated users are rating this contest because today is KPI open, an on-site competition which I am not able to participate in. No, wait, not today, tomorrow. Wait, then I don't know why people are not right, and maybe they are just not interested. This is very sad. This is very, very, very sad. Okay, disregard this. This is probably an alt, right? But still, this is likely. I don't understand why not get E. Probably people just don't like DP. Understandable, by the way. But this is a very bad sign for us, or this actually as well. So I really don't know. I don't know what should I do. I kind of want to solve it, but it does not look like. Oh, you can filter except for Japan. Interesting. Oh, by the way, Josh is participating and is not getting stupid penalties. Respectful. I wonder what is this problem all about. By the way, I just, yeah, like this. This sounds kind of suspicious. Like, okay, this part, ignore it. We can compute it later, right? Like, what is binomial coefficient, if you think about it? It is this factorial over this factorial, and then over this factorial and this factorial. Now this factorial, ignore it, just here. Now this may not look very good, but what it actually is like this, I think. These numbers are very dependent. Okay, what happens if I take several such numbers? Imagine I increment n by 1, small n. Or imagine that I take the complement, right? So now my number is this. It looks much better, actually. Like we get rid of this, This is now just this. Does it help in any way? Is anything 0 here? Okay, never mind. I don't really like compute the sum problem. Sounds like project other and not as a normal problem. So, and I really want to see that restart. So probably that's it for today. Sorry for a very short screencast, but that's what we got today. Bye.